In this video, we're going to discuss how to sketch a quadratic graph when we're just given its equation. Now, with this one, there's quite a few bits that we need to be able to do, so I've created a checklist for us, okay? There's 5 steps. The first thing we're going to do is we're going to draw the axes, as shown. We're going to find the y-intercept, then find the roots, and the turning point. We'll mark all those onto the graph, and then we'll sketch the curve afterwards, okay? Now you'll notice that I'm doing this on blank paper. This is why we're saying it is sketching rather than drawing accurately. In terms of a lot of maths papers, whenever you're doing any kind of sketching quadratic graphs, you're going to be given blank paper. So they're more interested in the location of each of the points and what the shape of the graph is going to look like. So we'll just get straight on with it. First thing I'm going to look at is sketch the graph of y equals x squared plus 5x plus 6, labelling clearly the points of intersection with the axes and the coordinates of the turning point. So pretty much everything we need to do here. Now step 1 does say draw the axes. So that's what we're going to do. Move this up a bit. Draw these axes in straight away. I'm just going to do it over at one side so I've still got place on the other side for working, okay? So it's just a rough sketch, but even with a rough sketch, we still should be drawing our axes with a straight line. X and Y. Please make sure you're labelling your axes and where the origin is going to be. Now, the first thing they're asking for after that is the y-intercept. So the y-intercept is where it's going to cross the y-axis. Just a little reminder, that means that the x coordinate anywhere on here is going to be 0. So what I can do is I can say, well, when x equals 0, that means that y equals, every time I see an x, I'm going to replace it with a 0 in this formula here. 0 squared plus 5 times 0 plus 6. Y equals 0 plus 0 plus 6 is 6. So we've got the y-intercept at 0, 6. 0, 6, let's just say that's there. Done. That's the first step done. The next thing we're asked to do is to find the roots. Now the roots are just where it crosses the x-axis. So it could be crossing anywhere along here. So if that's the case, just as x is equal to 0 on this one, this means y equals 0 going this way. So we now have when y equals 0, this means x squared plus 5x plus 6 equals 0. Now we've seen examples like this before. We have to find the roots. It just means we can use the quadratic formula if we wanted to, or we can just factorise. My preference is always to try and factorise first. If you can factorise, makes it a lot easier than examples where you've got to do the quadratic formula. They're quite a long amount of steps. So we've got trinomial, 2 pairs of brackets equals 0. 2 values times together to give you x squared, x times x. I want 2 numbers that times together to give you 6 that add up to give you 5. 2 numbers times to give you 6 add up to give you 5, 2 and 3. And they add up to give us positive 5 if that's positive and that's positive. Okay? Make your either or statements either x plus 2 equals 0 or x plus 3 equals 0, which means that x equals minus 2 or x equals minus 3. Well, that's easily done on here. So there's minus 2 there. There's minus 3 there. Notice it's not a completely accurate diagram. Nobody said it had to be accurate. As long as the points are in the general area that they should be, that's all that matters here, okay? Now, we have to work out what the turning point is next. That was the next little bit, find the turning point. There's 2 ways of doing this. Now, we could say that the distance between here and here is 1. So our turning point would be halfway between these two. So it would be at half of 1 is 0.5. So it should be somewhere around the minus 2.5 mark. So minus 2.5 would be in there. Now, if x is equal to minus 2.5, we can substitute that back into this equation. So turning point when x equals minus 2.5. Now, this is where we might end up needing a calculator. Y equals minus 2.5 squared plus 5 times 2.5 plus 6. And if you've got a calculator, that's very, very easy to do. Minus 2.5 squared plus 5 times, so that's a minus 2.5 there, minus 2.5 plus 6 gives us negative 0.25, so that would be a point round about there. So just X marks the spot. We've got negative 2.5, negative 0.25. Okay, now we've got all those points in there. What we have to do is sketch it. And that's you. So you've got 1, 2, 3 points being marked in terms of the 3 points where it crosses the axis, and we've labelled the turning point at minus 2.5, minus 0.25. Now, I know some of you will be unhappy with having to do 2.5 squared and 5 times negative 2.5. So there is an alternative way of doing that turning point. Let's just have a look at that very quickly. We could use the completing the square method. So for those of you that remember this, x squared plus 5x plus 6 equals 0. We can say then, or rather y equals that. Let's just get rid of that bit there for now. This is when we're putting it in the form x plus a all squared plus b, and our turning point therefore would be negative a b. We've all seen that from earlier on in the quadratics topic. So putting this back into completed square form, remember that plus 6 comes out the side, squared there, the x squared turns into an x, and we operate the half it, square it, and minus it method. So half of 5, I'm just going to write it as a fraction just to save time, 5 upon 2. We then square this number, and to square a fraction, it's top squared over bottom squared. 5 squared is 25, upon 2 squared, which is 4, and we minus that. Okay? So now x plus 5 upon 2, all squared, minus 25 upon 4. We have to incorporate this plus 6 in here somewhere. So let's just say that's 6 upon 1. And we're going to times top and bottom by 4 to get the denominators to be the same. So 6 times 4 is 24. 4 times 1 is 4. So we're going to now go minus 25 upon 4 plus 24 upon 4. That would end up with x plus 5 upon 2, all squared. Minus 25 plus 24 is minus 1 upon 4, which gives us the turning point. Remember, this one here changes the sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. So this is positive 5 upon 2. And our turning point becomes minus 5 upon 2, comma. And then the b stays the same. So minus 1/4. And for those of you that want to leave it as decimals instead, minus 5 divided by 2 is minus 2.5. And minus 1 divided by 4 is minus 0.25, which is the alternative way of doing that. Okay? So there you have it. That's your first one done. Now, the next one that I'm going to show you is a little bit different. Now, not as we saw before with discriminant, not every single graph is going to cross the x-axis twice. And you might end up with a question that says something along those lines. It says, sketch the graph of y equals x squared plus 4x plus 7, labelling the coordinates of the turning point of the curve and the point where the curve crosses the y-axis. Now, the question's actually spelling out to you that it shouldn't be crossing the x-axis at all. But let's just prove that that's the case, okay? We've got a equals 1, b equals 4, and c equals 7. So from our discriminant formula, b squared minus 4ac, well, that's going to be 1 squared minus 4, so 4 squared even, minus 4 times 1 times 7, 4 squared is 16, minus 4 times 1 times 7 is 28, and even without calculating that, we can clearly see that's going to be less than 0, so no real roots, okay? So that's that step over and done with. We do not need to find roots for this one. Well, we can do the rest really quickly then, so let's just battle through this as quick as we can. X, Y, and the origin. First, so after we've drawn the axis, was to find the y-intercept. So remember, this is when x is equal to 0. So when x equals 0, y equals 0 squared plus 4 times 0 plus 7 which we can see is going to be 7. So 7. Okay. We know it's not going to cut the x-axis at all. So let's just go straight to completing the square, because obviously we have no roots to sort of find the midpoint from. Complete the square with this, and that should tell us the turning point. So y equals x squared plus 4x plus 7 in the form x plus a all squared plus b. We're going to have the plus 7 out of the side. X squared turns into an x. Half of 4 is 2. Square it gives you 4, and we minus that answer when it comes out the brackets. So we get x plus 2 all squared minus 4 plus 7 minus 3. And just as before, when we said that our turning point, when it's in that form, is going to be negative AB, we can say this is going to be turning point of negative 2, negative 3. Okay, so that's us. We've now worked out the turning point. We've worked out the y-intercept. Let's just put the turning point in. Minus 2, 3, be maybe there. Minus 2, no it wouldn't. Sorry, it's minus 2, minus 3. See, again, it's me making mistakes. Happens to us all. Okay, so minus 2, minus 3 is down here. We know from the graph that this is a positive x squared, so it's going to do something like that. And I've made an error. Where have I made the error? Ah, of course, right. Minus 4 plus 7 is positive 3. So I was right with the coordinates beforehand. It's just for the wrong reasons. Right. Third time lucky. Okay. So let's try that again. Minus 2, positive 3. There we go. So otherwise it was going to end up with 2 roots, and we don't want that to happen. It says here it can't have any roots. So there we go. Minus 2, 3. Sketch the graph in. Off it goes. And that's us. Because we've now stated the equation. So the coordinates of the turning point and the point where it cuts the y-axis. Turning point, y-axis, done. So try some examples for yourself, and I'll see you in the next video. Thank you.